In this lesson, I'm going to talk about what is underfitting and overfitting. This is another most widely asked question in a data scientist interview. To make it understand in a better way, I would like to first draw a figure. For example, let's say you have a data set which is binary classification. I mean, the data set have the two type of the classes, and let's say these are the classes points. Okay, and here you have the another one. Let's make it like this. Okay, and in the another one, let's say you have this one. Okay, all right, perfect. So let's say you have these classes, and what I'm asking you, let's say this is for class 1 and this is for class 2, and similarly this is for class 1 and this is for class 2. I mean this black and blue line. If your model is in underfitting, if your model is underfitted, then it might not be able to classify all the classes in a very accurate manner. So it will draw a line something like this, let's say. So what it will do, it will also misclassify something. Okay, it will misclassify some classes, and then this model could be underfitting model. Then if model is your overfitting, if your model is overfitting, it will try to classify very accurately. That means it will learn your data very accurately. Okay, so this boundary line, which is the boundary lines are this one and this one. So in an underfitting model, boundary line would be very much smooth and linear, but in overfitted model, this boundary line may not be the smooth and the linear. So this will be very jiggly wiggly, and in which this will try to classify it very accurately. So what happens here, it will try to learn everything, and while trying to learn everything, it will introduce low bias and high variance. And while if your model is underfitted, then there would be a high bias and low variance. A low variance means there would not be the much variance in the boundary line. That's mean, and the predicted value would be mostly concentrated at a single spot. So these are the underfitting and overfitting definition. Now the question comes, how you can tackle this underfitting and the overfitting. So there are many ways to tackle this underfitting and overfitting. Those ways are either you can use the L1 regularization or L2 regularizations. Otherwise you can also use a dropout. So the dropout is mostly used into the deep learning, but this L1 and the L2 regularizations are used into classical machine learning as well as into deep learning. So L1 and this L2 regularization, this L1 regularization is also known as lasso regression. This is also known as lasso, and this one known as ridge regression. Okay, so this is lasso regression and this is ridge regression as well. So these L1 and L2 regularization adds some factors into the weights of the classifier, and if weights are high, then the cost function will be the high. So in this way, machine learning always try to put the low weight so that the loss function should be low. All right, so in one line, what you can say, in underfitting model your accuracy may not be the accurate on the training set, but in overfitting model your accuracy would be very high in a training set, but model would not be able to classify unseen data properly. In underfitting model there is high bias and low variance, but in overfitting model there is low bias and high variance. And the underfitting and the overfitting can be avoided. In fact, overfitting can be avoided by using L1 and L2 and the dropout regularization, and underfitting can be avoided by using a cross validation. Okay, perfect. Thank you so much for watching this video. Please do not forget to like and subscribe this channel so that you can get updates directly into